Our first speaker is Dr. Tom Suchanek. He's a marine ecologist and emeritus scientist from UC Davis. He spent most of his career conducting research on environmental contaminants and is now addressing the most critical contaminant of our time, carbon dioxide. He'll be giving an overview presentation on global and local climate change impacts and the urgency to develop solutions to solve this crisis. So I will go ahead to Dr. Suchanek now.
Well, thanks, Philip, for that nice introduction. And thank you and Dr. Barra for inviting me here today. What I'd like to do today is to give a very brief overview of climate change globally and some examples of how that affects us here in Sacramento, as well as show you the urgency of addressing our climate change crisis. So with that, let's begin with the basics. And the basics are the greenhouse effect. Here is the natural greenhouse effect on the left and the human-enhanced greenhouse effect on the right. The sun beats down on the earth. Some of that heat is absorbed by the earth. Some of it's reflected back out into space. However, because of some of these greenhouse gases, carbon dioxide, methane, and nitrous oxide, that puts a little warm blanket over the earth of heat-trapping gases. Without those gases, our planet would be ice, basically. But it's not. We really rely on some of those gases, but not too much. So let's look at the human-enhanced greenhouse effect. Same process. Sun beats down on the earth. Some of that heat is absorbed. Some of it's reflected back out into space. But because we've produced and emitted so many more of these greenhouse gases, carbon dioxide, methane, and nitrous oxide, we have a much bigger blanket of heat-trapping gases. And that's the problem. That's the problem we're trying to deal with. So greenhouse effect creates global warming, which then drives climate change. Today, I'm going to focus primarily on carbon dioxide, since that's the biggest issue we have to deal with. There are other greenhouse gases besides methane and nitrous oxide as well, but today we'll focus primarily on carbon dioxide. So fossil fuels and the emissions of fossil fuels and the burning of fossil fuels, carbon dioxide, coal, oil, and gas are responsible for about 94% of the total carbon dioxide emissions from human sources. And coal represents about 42% of those emissions, oil 33%, and natural gas 19%. Cement plants also add another 6%. So the global community has been emitting about 100 million tons of carbon dioxide every day into the Earth's atmosphere, and that adds up to about 40 billion tons of CO2 per year. Now that's almost incomprehensible, because CO2 is a gas. I mean, how can it be possibly that much weight or that much mass into the atmosphere? But it's true. If we add on the other greenhouse gases besides carbon dioxide, we end up with about 51 billion tons per year, an enormous amount. So that's what we have to deal with. So let's look at the sources of greenhouse gas emissions in Sacramento County. First, we have transportation. Off-road and on-road vehicles releases about 40% of our greenhouse gases. And next in line is the residential energy usage, about 25% of our greenhouse gases. And finally, the next one in line, 18% for commercial and industrial manufacturing. So those are the main things we need to worry about when we're looking at climate action plans. So let's go back in time a little bit and talk about carbon dioxide. On the left, we have carbon dioxide concentrations in parts per million. And on the bottom, we have time all the way back to 800,000 years before the present. So this yellow line up and down represents carbon dioxide fluctuations over time. Every time it dips down, that's another ice age. And we continue along that line until about 200,000 years ago, when humans first appeared. As we go then towards the future, where we are now, about where we are now, we encounter the Industrial Revolution, which started about 1800, where we started burning coal to drive our machinery and the steam engines. And then from there, you can see visually, it's just gone straight up to about 415 parts per million. That's not a special number. It just shows you that it's going exponentially higher and higher all the time. And that's what we need to stop. So let's take a look at the relationship between temperature and carbon dioxide. So on the left, we have temperature increase since the Industrial Revolution, and that's going up to about 1.2 degrees Celsius. And on the right, we have the concentrations of carbon dioxide, like I said, 415 parts per million. So as carbon dioxide, which is the white line, increases over time, it goes up almost exponential here. And then the temperature, which is in the blue line, is quite variable, but it's also correlated with carbon dioxide, increasing all the time. The last time concentrations were 415 parts per million of CO2, humans didn't even exist. That was 800,000 years to 20 million years ago. And global temperatures at that time were substantially higher. There was almost no ice on the planet, and sea level was 100 foot higher. Now, I think most of you know that Sacramento elevation is about 25 feet above sea level. So where would your house be if we had 100 foot higher sea level? Think about it. So here we have the 10 hottest years on record globally, with 2016 being the highest temperature there. If we add 2020 on there last year, it was equivalent to the hottest temperature we've incurred on Earth so far. So both of those are going higher and higher all the time, and we need to stop that increase, which has lately been causing rolling blackouts because the electrical system is failing because so many people are trying to use their air conditioners. So this is part of the problem. In Sacramento, we encounter tremendous heat in the summer, sometimes 100 to 110. The highest temperature in Sacramento has been 115 degrees. That's really hot. But the hottest air temperature recorded on Earth was just this last August, 130 degrees in Death Valley. Now, I don't want to see much of that happening anymore. However, if we continue on emitting and exposing carbon dioxide and other greenhouse gases into the atmosphere at the rate we're going now, by the 2040s, it's expected that Sacramento will be experiencing 128 degree temperature. That's something that I don't think any of us really want. And with the heat comes drought. And this is an example of a drought in 2012 to 2017. You know that we're in a drought situation now. And let's take a closer look at California over here. This is California, and there's different levels of drought. There's abnormal drought, moderate drought, severe drought, extreme drought, and that last category, exceptional drought. Now, until this drought here in 2017, this exceptional drought category didn't even exist. Scientists had to create a new metric and a new color to even describe this drought, this level of drought. Now, I didn't show the example, but you did see it in the splash slides initially. This condition of this level of drought with the exceptional drought is expected this summer. It's there now, and it's expected to continue. Let's take a look at wildfires greater than 1,000 acres on Forest Service land. On the left, we have the number of fires. Each one of these bars is 1 year. And on the bottom, from 1970 to about the present. And you can see that in the 1970s, there wasn't much going on. Well, we had a few fires, 50 fires or so. But as we come closer to the present time, it's highly variable. However, this orange line is the running average of all of the abundance of fires. And this just keeps going up, and it's trending towards an exponential increase. Besides that, California's fire season has increased by 75 days across the Sierra Nevada. That's both earlier than the present and then later than the present, or what was the present. And who knows, one day we may have the entire year being a California fire season. So we need to be careful about what we're doing. So let's take a look at those fires. In 2020, we had over 9,900 fires in California. That's just phenomenal. And the firefighters were fighting 5 of the 6 largest California wildfires in recorded history, all at the same time in September. So in terms of acres burned, these are the 5 largest acres burned years. CAL FIRE data shows us that about 3.2 million acres were burned last year in 2020. But if we now add the US Forest Service data onto that, it's really 4.2 million acres burned. And we're expecting similar effects this coming summer. So where there's fire, there's smoke. Absolutely. And that smoke is what's affecting us. Give you a couple examples. This is the Woolsey fire in Malibu in 2018. This is when they had to close Route 101 because there was so much smoke on the road you couldn't see where you were going. Tremendous result of that fire. And here's Sacramento Tower Bridge on a good day. Here it was last summer when we had that tremendous, in September, had that tremendous air quality damage to us. And let's take a look at that air quality index, which goes from 0 to 500. Here's a map of Sacramento County. If we take, in kind of odd shape, but if you take this map and plop it right on top of this right-hand area, this is the Sacramento right in the middle, we take a look at the actual air quality indices. The red area is unhealthy air quality 151 to 200. The purple area is very unhealthy air from 201 to 300. And that brown blob up above is hazardous air, 301 to 500. That's when we were told to stay inside, get filters for our house if we could, don't exercise, don't go out and bike. So that was a tremendous time on September 12th of last year where we were really suffering from the smoke. But it's not just smoke from forest fires. Scientists from Harvard University just published a paper recently showing that the exposure to particulate matter, and that's PM 2.5, that's particulate matter in the 2.5 micron range, that's microscopic, accumulating in people's lungs from fossil fuel emissions, burning fossil fuels specifically, not forests, accounted for 18% of global deaths in 2018. That's over 8 million deaths that year just from the burning of fossil fuels. So that's something that we really need to do, is to get rid of these things. So what's our solutions? We have many solutions. I'm only going to touch on a couple today. We don't have time for all of them, but we need to transition into alternative energy sources, and we need to reduce and eliminate fossil fuel use. So let's take a look at that. One of our best options right now is solar with an endless renewable resource, right? Well, not quite. Our sun is only going to be around for about 4.5 billion years. So we really need to get this thing going and solve its prices. So the US relies on about 2% of solar for their energy needs, but California is a little ahead of the game. We rely on 20% solar for our energy needs. And the good news is that this is mostly from photovoltaic cells on rooftops, but the cost of photovoltaics has gone down 99% from the 1970s, and it's actually still going down now. The second option for us is wind. So 5% of the world's energy comes from wind, but 7.5% of our energy in California comes from wind as well. Most of that is land-based wind turbines, and this is probably more familiar to most of you, the Altamont Pass wind turbine farm, which is one of the oldest and at one time the largest wind turbine farm in the world, not anymore. But in addition to land-based wind turbines, we have the option for offshore wind here. There's been a bill submitted to the Assembly in California to require some level of offshore winds. We have tremendous winds on the coast, which could accommodate this. So they're talking about doing prototypes up in the northern coast. So we need to electrify everything, especially transportation. Remember, I told you that 40% of California's carbon emissions are coming from transportation, but it's only 28% in the rest of the country because California has so many more cars, we're producing that much more carbon dioxide into the atmosphere. But good news, Governor Newsom signed an executive order last year in September to halt the sales of all new gasoline cars and trucks by 2035. And also good, January 25th, President Biden set a goal to convert the entire federal fleet to electric vehicles. That's great news. And 3 days later, General Motors announced it will only sell zero-emission vehicles by 2035. This is really gaining a lot of momentum right now. And over a dozen countries have committed to banning new gasoline automobiles over the next 1 to 2 decades. That's fantastic news. We just need to keep on that and move faster if we can. So I'm gonna walk you through this graph. It looks complicated, but it's not. This is the same graph I showed you before of the axis of billions of tons of carbon dioxide being emitted into the atmosphere, up to 40 billion tons a year. On the bottom is a time from 1980 to about 2100, the end of the century. So this black line is the annual increase in carbon dioxide emitted into the atmosphere. So if we started in the year 2000 to limit our carbon dioxide, we would have only had to reduce our carbon dioxide emissions by 2% per year. Well, obviously we didn't do that. We kept going higher and higher and higher, and here we are now in the year 2021. If we start now, we will have to reduce our carbon emissions by about 5% per year. Now, each one of these little lines is a model run indicating how fast we would have to reduce those emissions. So in 2000, we would be one of these yellow lines. In the 2021, it would be this red line going down here until we get to the place where we want to be, which is zero emissions. So now we're here, but here's 2030. If we wait until 2030 to start this process, we would be at that blue line there. And that would mean that we would have to reduce our carbon emissions into the atmosphere by 9% per year. That's almost unfathomable. I mean, we would have a really hard time doing that, plus having to have all the other countries of the world basically do the same thing. So I'm very pleased that Biden's goal was set on Earth Day last week to lower greenhouse gases by at least 50% by the year 2030 and have net zero greenhouse gases by 2050. So those are our goals, and hopefully we can accomplish that. So at this point, we have this situation going on with three crises all at the same time. Here's COVID-19. We have 1 to 2 years. We'll probably be dealing with this. The economy is in recession. We have a totally unstable situation where the stocks are going up hundreds and hundreds of points each day or down hundreds of points. We're probably going to be dealing with that for 2 to 4 years. And overwhelming all of this is climate change. We're experiencing those extreme impacts right now. And this is an existential threat that's facing us. If we don't do something about this now, this will be much huger, much bigger, and more devastating than anything else we've ever encountered. And this would go on to infinity if we don't deal with it. So an expanded presentation of this is found on my website if you're interested. So at this point, I'd like to run over this graph. I'm going to walk you through this in preparation for Kathy Dodson's presentation on En-ROADS. So on the left, we have temperature. We've sort of seen this before, increasing in Celsius degrees. And on the bottom, we have time from 2000 up to the end of the century. Now, this was the temperature back here. If we assume this green line was pre-industrial temperature, this is all increase above pre-industrial temperature. So right now, this blue line here is how far we've gotten in terms of increasing temperature since the Industrial Revolution. Right now, we've reached about 1.25 degrees. And the Paris Climate Accord goals are that we should not exceed 1.5 degrees Celsius, or at the very most 2 degrees Celsius, in order to save us from the most extreme impacts from climate change. So we're here now, and if we continue on with what we're doing, which is called the model of business as usual, and we go there to the year 2100, we would reach a point where we were 3.6 degrees Celsius above the pre-industrial revolution, or in Fahrenheit degrees, we'd be 6.5 degrees hotter. This would be devastating and cause a tremendous existential threat to human civilization. We don't want to be there. So at this point, I'm pleased to introduce Kathy Dodson from the Citizens Climate Lobby. She will be showing you a climate simulator developed by En-ROADS, which is the MIT Sloan School of Management in Cambridge, Massachusetts. And Kathy, I'd like you to take it away from here.